If you were driving at 70 miles per hour, it would take you about 15 days to circle the Earth's equator. At the same speed, reaching the Moon would take around 5 months, driving to Mars would take 63 years, and reaching Neptune would require roughly 4,400 years of non-stop travel. Our solar system is enormous. In 1977, NASA launched Voyager 1 at a speed of 38,000 miles per hour, and even then it did not leave the solar system until 2012. That means it traveled at that incredible speed for 35 years just to exit our cosmic neighborhood. Even light, the fastest thing in the universe, capable of circling Earth 7 times in 1 second, seems slow when compared to the vast distances in space. As we zoom outward, the true size of the solar system becomes even more staggering. It normally takes light 8 hours to travel from the Sun to the outer regions, but in visual animations we cover that distance in under a minute. Still, the solar system is tiny compared to the Milky Way galaxy. The Milky Way contains an estimated 300 billion stars, many with their own planets. Our closest neighboring star system, Alpha Centauri, is 4.3 light-years away. To help visualize this, if we shrank our entire solar system to the size of a US quarter, Alpha Centauri would be about 300 feet away. Even Voyager, traveling at 38,000 miles per hour, would need 77,000 years to reach it. Space is unimaginably vast. Surrounding our solar system is the hypothetical Oort cloud, a massive sphere of icy bodies that extends roughly 1 light-year from the Sun, hundreds or even thousands of times farther out than Neptune. After more than 4 decades of travel, Voyager has only made it a small fraction of this distance. As we continue outward, we encounter stars like Betelgeuse, which is about 640 light-years away and nearly 1,000 times larger than the Sun. The light we see from Betelgeuse tonight actually left the star around 100 years before Christopher Columbus sailed to the Americas. Yet in cosmic terms, Betelgeuse is still relatively close. Earth's earliest radio transmissions, sent out over the last century, have formed a radio bubble reaching about 15,000 nearby stars. That is only a tiny fraction of the stars in the Milky Way, showing just how small our influence is on a galactic scale. Returning to the quarter analogy, if the solar system were the size of a coin, the entire Milky Way would be as large as North America, with 300 billion other quarters scattered across it. Each one represents a star system with its own planets. We are simply one tiny point in a massive sea of stars. Beyond the Milky Way lies even more wonder. There are at least 1 trillion galaxies in the observable universe. A trillion is a million multiplied by a million, an almost incomprehensible number. To visualize it, imagine 1,000 cats, then imagine 1,000 more groups of 1,000 cats each, that makes a million. Now imagine every one of those million cats representing another million. That's what a trillion represents, and that is how many galaxies exist. Our nearest major galactic neighbor, the Andromeda Galaxy, sits 2.5 million light-years away and is moving toward us at over 670,000 miles per hour. When it eventually merges with the Milky Way, almost no stars will collide because the distances between them are so enormous. The collision will be mainly gravitational. As we zoom outward further, we see our local group of galaxies, then the Virgo cluster containing more than 1,500 galaxies, and then the Virgo supercluster with around 20,000 galaxies. This supercluster is part of an even larger structure called Laniakea, containing about 100,000 galaxies. And the observable universe includes roughly 10 million superclusters like this. These mapped galaxies represent only a fraction of what actually exists. Countless more remain unseen because their light hasn't reached us. Dust and stars within the Milky Way obscure parts of the sky, forming the zone of obscuration. Light from distant galaxies has taken billions of years to reach Earth, allowing us to look deep into the past whenever we observe the night sky. Eventually, we reach the cosmic microwave background, the oldest detectable light, left over from the Big Bang. Beyond the observable universe, many more galaxies exist, but the light from them hasn't yet reached us. Because space is expanding, much of that light may never reach Earth. Scientists estimate that the entire universe is at least 250 times larger than the observable portion and possibly infinite. This raises profound questions. What is the universe, and what are we? It's easy to feel insignificant, like a tiny creature on a tiny planet in a forgotten corner of the cosmos. But there is another perspective: we are part of this vast and mysterious universe. We emerged from it, and we are inseparable from it. Modern thinking often makes us feel alone, but this is an outdated worldview. Humans and nature are deeply connected. You are not outside the universe, you are within it, just as a skin cell is part of the human body. You grew out of the universe and remain tied to it. Even from a strictly scientific perspective, everything in your body is made of the same particles found throughout the cosmos. As Carl Sagan said, we are made of star stuff. We are a way for the universe to know itself. Quantum physics adds that everything in existence is made of interconnected fields of energy. If the universe began as a singularity, then everything was once unified. Our definition of life is also evolving. The boundary between living and non-living has shifted over time, expanding from humans to animals, plants, cells, and even viruses. There is no universally agreed upon line separating life from non-life. What if life is more fundamental than we assume? The universe is not a static machine, it is dynamic, evolving, and full of motion. In many ways, it behaves more like a living organism than a clock. Perhaps the universe has forms of intelligence beyond our understanding, just as a single cell cannot comprehend the entire human body. If we are alive and intelligent, and we are inseparable from the universe, then it is reasonable to consider that the universe may also possess a kind of intelligence. Our simplified scientific models often fail to capture the full complexity of nature, planets, stars, and galaxies. We may be living on an intelligent planet, inside an intelligent galaxy, within an intelligent universe. We know almost nothing, which is why we must remain open-minded. Ultimately, we need a new worldview, one that sees us as connected parts of a living, intelligent whole, rather than isolated beings in a dead universe. Our beliefs shape our culture and our future. A worldview based on unity, purpose, and interconnection could guide humanity toward growth and understanding. Each of us is here for a brief moment, experiencing our own journey through the cosmos. When our time ends, perhaps we return to the greater source from which we came. The choice is between viewing the universe as cold and empty, or recognizing that we are an essential part of something vast and extraordinary.